All right, next up we have the natural exponential function. Natural exponent, of course, is e. So ln is the natural log, which is another word of saying natural exponent, and the base is e, which is the natural number or Euler's number. We talked about this before, but now we're going to get into it much more heavily. The natural exponential function is given as the inverse of the function of x is e to the x power. And what that means is that y is equal to e to the x power if and only if x equals the natural log of y. And we're going to do a number of problems that shows this, but remember, it means natural log means the exponent of the natural number. And that's the bottom line for that. This is something that is just, it's going to seem redundant, although we're putting it in the context of natural numbers. But when you multiply two like bases, remember you add their exponents, so if the base is e, then you still add it, it's still the same thing. And if you divide two values of the same base, you take their exponents and subtract, just like you've done many times before. The properties of the natural exponential function is that the x values for e to the x power can be anywhere from negative infinity to infinity, and the range, or the y values, or the f of x values, is anywhere from 0 to infinity, not inclusive. The function f of x is e to the x power. That is continuous, increasing, and one-to-one on its entire domain, meaning that if you were to draw a horizontal line, it's only going to intersect that curve one time. And it is concave upward on its entire domain. So it means it's going up and so like the curve, the shape of the curve is facing upward and not downward. If you were to graph y equals e to the x power, you get a good idea what it looks like. We're going to do some problems now in which we're going to be combining e and natural log so you can see what they're referring to here. In the first one, I went ahead and did it. E to the natural log of x means that e that has an exponential value of x means that it's going to be x. That is what that's saying. The natural log is the base of e, and it gives you that value being x, so that means x is equal to 4. Nothing had to be done on the right-hand side. In this one right here, we want to get rid of the e in the e to the x power, so we take the natural log of both sides. And this gives us x equals natural log of 12. And that value turns out to be 2.49. Just type out ln 12. You'll get that answer round out. I like to use 3 significant figures. Number 5. Okay, this is an algebra problem. We treat this like just one big hunk of x, and then we deal with that part when we get everything else cleared away from it. So we subtract 9, and we get negative 2e to the x equals negative 2. And we divide both sides by negative 2. And e to the x equals 1. And remember, anything to the 0 power is 1, but if you're not sure about doing that, you can figure that out with your calculator. But x is indeed going to be equal to 0. If you want to find out, you simply hit the natural log of 1, and you see that you will get 0. Natural log of e to the x. In fact, I'll just go ahead and write that down as a possible step going from here to here. So the natural log of e to the x equals the natural log of 1, and that will lead us to x equals 0. Do the same kind of thing over here. Divide by 50. E to the negative x is equal to 2.6. You take the natural log of both sides. If negative x is equal to negative 0.511. Multiply both sides by negative 1, and x equals 0.511. Okay? Number 9, I'm going to get rid of the natural log this time, so the inverse of the natural log is the e to that value. So e to the natural log of x power, that's going to cancel out to leave us, and then I have to do the same thing over here. So it leaves us x equals e to the second power. And punch that out in your calculator, and you find that e is equal to 7.39. Problem number 11, same things we did over here. Take e carried to both sides. That cancels out. That right there. Gives us x minus 3 equals, we already did that over here. E to the second power is 7.39. Add 3, and x equals 10.4. Pretty significant figures. Okay, last one. A little more involved, but not too bad. Again, we want to get rid of the natural log. So you take e caret both sides. And this gives you the square root of x plus 2 equals e to the first power. And you type that in, you get this 2.72. So that might be a number you might want to remember, particularly if you're in Scholastic Bowl, int, where this is the value of e, is 2.718, blah, blah, blah. Now I have to get rid of the square root, so I'm going to square both sides by that. So x plus 2 equals 7.39. Subtract 2 from both sides, and x equals 5.39. There you have it. Your practice problems. Through 14 even on page 356. Have fun.